Leonard.
All right, thank you very much, Richard. Thank you, Jackie. I'm hoping everyone can hear me.
Yes, you are
Yes, we
audible and
can.
we can see you as well. Yeah.
Perfect. Thanks. So thank you everyone for joining this conversation. I think it is a conversation, considering the topic that we are going to be talking throughout this or having conversations about in this forum. It's pretty broad. So I know most of us have heard of 5G. It depends on how you've had it. Some of us have had it in good light. Some of us have had it as a bad or a vice. But I'm hoping that we are going to debunk some of these myths in this forum. But at the same time, open up the flow for future discussions on 5G. It's a broad topic, so I do not really expect, for the technical guys, I might disappoint them because I'm not going to go into the nitty-gritties of some of the technology terms and all, and some of the things that are building up of 5G. But being the first the first forum to get to discuss 5G, and probably I think would be in the country as at now. I mean, apart from the deployments that you've already had Safaricom has begun doing and all. So I'm just going to give everything high level and make it what it is, like an initial conversation. And then feel free to engage. And I also look forward to hearing some of the questions that are probably packaged in the myths or in the facts of the 5G itself. So my name is Leonard Mabele, and I work with Richard Otolo at I Love Africa Research Center of Strathmore University. Currently, I'm a research fellow in the telecommunications space. I'm, doubling up as a PhD student as well. And then I also lead the Internet of Things research team. So the Internet of Things research team is the team that looks at how you get to go deploy sensors and networks and be able to collect data more intelligently and create some more intelligent ways of analyzing and developing insights out of that data. So I'm just going to share my slide and then we can begin this conversation. I've made the slide brief. I think it's a 15-page slide. And it's pretty much leaning on the technology side of things, but I'll definitely be breaking down some of the components that are part of this. So let me share just my screen, then we'll get started. Yeah, there we go. That's the first page. I'm hoping everyone can see it. So having given an introduction about myself, I'm just going to go to the next slide. And maybe so in this slide, what I was just giving is an overview of what radio frequency spectrum is about. I mean, so radio frequency is kind of the lifeblood of technology in any country. I just want all of you to be aware of that. And we interact with radio frequency in different ways. I mean, right now we are using the services of the internet where the radio frequency is involved somewhere. And in our homes, you also have televisions. And again, that is using radio frequency. We all have mobile phones just next to us throughout this slide. And some of us will probably are going to be receiving texts and calls coming in at the same time. And that is still making use of the radio frequency. And to make it more interesting, our phones come with GPSs, and we can be able to now open up some applications like Uber, Bolt, and be able to order some of these services. And that is making use of the radio frequency still because of the GPSs. And we also have Wi-Fi in our homes, and I presume most of us are logged into this call over Wi-Fi, the Wi-Fi networks in our homes. That is still using the radio frequency. So you all, if you are to look at what radio frequency spectrum is, it's pretty much the lifeblood of any technology, of the entire technology in any ecosystem, in any country, or name it. So it's basically a portion of the electromagnetic spectrum. For those of you who studied physics back then, you can remember what the electromagnetic spectrum was. And it just ranges between 3 kilohertz and 300 gigahertz. I'm mentioning that because when we get to the bit of 5G, you'll understand why the frequencies are worth mentioning like that. And so in terms of looking at the utilization of the radio frequency itself, it's dependent on different parameters or different aspects. And largely it's just physical, economic, and legal at the same time. So physical in the sense that where are you located? So where you're located will actually determine what frequency you can use, depending on the services you could get there. And location, again, at the same time, is referring to, your geographical spacing at this point would mean you'll use base station X from Safaricom, and another person will use base station A from Safaricom or Airtel, and all that is still within what will be the location of variable of what makes, spectrum become usable. And then the legal, this is just an implication that is, and every country has to be, to have some order of things in terms of using the radio frequency. So some of you are aware, some of you are not, but in the country, the government actually regulates how we use the radio frequency, and it does that through the Communications Authority of Kenya. So that means now Communication Authority of Kenya are able to dictate this service will go to mobile networks, this service will go to television, broadcasting, and all. Otherwise, if we didn't have an ecosystem that has rules like that, then it would be pretty chaotic. So those are the three variables that make the whole understanding of the radio frequency spectrum utilization. And it's just, again, looking at the technology, it's just based on the transmission of the frequencies from point A to point B. What are the practicalities of the technology in terms of the antennas, etc. And then some of these frequencies, some can be shared by other services, some can be exclusively licensed to be used by specific operators, and pretty much playing within the space of the three variables that form the utilization of the RF spectrum itself. So I'm going to be sharing this slide. Some of these diagrams you'll get to interact with them. So what I have over there is the entire spectrum of the electromagnetic, looking at radio waves, microwaves, infrared, X-rays, gamma rays. So X-rays and gamma rays, really, we get to interact with those in closed doors, so you probably might not hear much about them. But anytime you hear radio frequency, it's actually covering the radio frequency allocation of the electromagnetic spectrum, as well as microwaves, okay? So this is a broad categorization of the entire EM spectrum, and I don't want to delve into these details because they're part of the EM spectrum, as you probably have heard of it before, and you'll be able to deal with this once I share these slides with you. So some of the frequency services, as I've mentioned, so FM radio. So FM radio in a country like ours, we have it operating from 8.87 megahertz, 87.5 megahertz, 108 megahertz. So when you're tuned to a radio, you get that channel through that frequency range. And then you have aeronautical services that are, again, run on the spectrum. Meteorological services, which is weather services, running on spectrum. Fixed mobile, UHF TV broadcasting, which I've already mentioned, 4G LTE. I mean, I think most of us on this call, our phones are actually 4G enabled, or they're 4G capable. So we're using a lot of the frequencies in the 800 megahertz. That's what we get through for 4G access. And then we have other services that probably you don't interact with every day, like the short range radios and whatever's, and GPS system, probably we never talk about it. But all of these things are just packaged within the whole box of the RF spectrum, running as services for us, because we don't care about the nitty-gritties in the background. We really don't talk about the megahertz like that, but they're really, part of what comes out of the RF spectrum. And I put a link on this slide down there where as a country and part of the standards body. So globally, the Communications Authority, globally, the standards for radio frequency utilization are spelled by the International Telecommunications Union, which is a body under the United Nations. So globally, it means frequency allocations done per region. That means, Europe, Africa, the Oceania, Pacific, and all. They are all harmonized by the International Telecommunications Union, working under the UN. And now down here, what I put is for our country, Communications Authority also publishes these frequency allocations as well. So down there, I put a link to the 2020 updated table frequency of allocations as given out by the Communications Authority of Kenya. So this conversation for 5G can never go without us talking about cellular communication, because 5G is the 5th generation of the mobile of the cellular communications. So cellular communications is the communications that happen it was kind of one of the paradigm shifts that changed the way we actually operate up to now. And now we've come to appreciate not even staying without a phone is not something that can work anymore for us. And that is because of the evolution in the cellular communication. So anytime you hear cellular communication, think about your mobile phone. So the mobile phone generations have come. We began off with 1G, which was looking at voice only. And then we went off to 2G, which right now we call it like as the backbone of the existing communications of mobile in any country. Because 2G is what allows the various people, farmers using the feature phones, us using the smartphones, and some groups using in the midway a mix of the feature phones and smartphones. So 2G is pretty much the backbone of it. It's what we call the GSM network. And that was just an improvement on voice and some of the low rate of data. And then we moved off to 3G and all. I think the next slide is actually better defined. We moved off to 3G, and then 3G was the beginning point for us to be able to have data-centric devices. By data-centric, I mean now we were able to start accessing internet, have that bundle experience. So the bundle experience was unraveled, or was given live, was brought to life in the 3G era, and that was in the 90s, in the mid 90s, 95 and all. And then 2000, I think most of us started experiencing the full 3G spelt out by different bodies who had given standards. So the group that came up to start working on 3G has been the group that has been pushing for evolution of mobile telecommunications to the level we are at now for 5G. Now, I understand Kenya has not really gone commercial on 5G, but a number of countries, pretty much a number in Asia, such as Korea, Japan, and China have gone all ahead. China has actually pushed the limits to begin 6G right now. In Europe, of course, quite a number of countries like the UK began the trials in 5G and all. So the body that was looking at all this globally, which began at the onset of 3G, is called the 3GPP standard. I mean, the 3GPP Alliance. So the 3GPP Alliance have been spelling standards as these evolutions have been happening. So now looking at the final, looking at 4G, the 4G phone over there is a bit smaller compared to the older phones. You guys must have seen the bigger phones that we used to have back then, and Motorola's and all for probably for the juniors, or some of the guys who were below 20 or within the younger ages of 20 probably ever saw such devices. But right now we've gotten to an evolution of 4G networks, and that is having a full-blown ecosystem of LTE advanced. That's what I have on the last picture there. So those are just evolutions of different standards getting us to where we are now in terms of broadband access. So we've moved off beyond voice, which was our flagships back in the 2G. So all this is being released by standards by 3GPP, and 3GPP did their releases from release 8 to release 15. By that I mean this is just more like support of the infrastructure, and then the support of this infrastructure, when it got to release 15, that's when developments for 5G began. Release 15 marked the beginning point of 5G. Now, but at the same time, we are not. We have continually evolved LTE. We've continually, continue to just have LG evolve to the LTE evolve to, and LTE is 4G, evolve to the best standards, because we still felt like the earlier releases were pretty premature to actually give us the best broadband experience. And then as that evolved to release 15, then we started feeling the 5G coming into our hands. So looking at all these things, what I've talked about, just the evolution of the same technologies, 2G operating in the 80, 90, and 960 megahertz of frequencies, having some small bandwidth or some small width that will allow us to do much. And then 3G again, at least evolved to 700, 1700 megahertz and expanded our bandwidth to like 5 megahertz. And that's when we started enjoying the broadband coverage going all the way up. And 4G came in with some bigger bandwidth, a bit like 20 megahertz. And then it operates in a number of frequency bands like the 800 megahertz, 900 megahertz, 1800 megahertz. Now, all these things I'm mentioning, it's coming as top of my head. They are all provided by the Communications Authority on their frequency table of allocations. So you'll also find what has been given for 5G, which I'm just moving off to the next slide. Now, 5G began, so as I've mentioned about the standards bodies, so ITU pretty much are the big bosses who are looking at the global harmonization of the radio frequency. So if you are going to be looking at any frequency in 5G or any conversation in 5G, you definitely have to go to reference standards of the ITU. So when ITU was looking at the future plan of broadband, they set up a whole thing called IMT 2020, which was more like looking at enhanced broadband, moving us to speeds of like 10 gigahertz, 10 Gbps, or up to 20 Gbps. So that was like the basis of IMT 2020, and ITU was pretty much push the standards out, trying to have enhanced broadband across the globe. But then again, something to remember is the standards in the background are also being developed by the 3GPP, who are the guys who are just looking at cellular networks, because ITU also has other responsibilities. And then what are we looking at for 5G in terms of features? So 5G is just looking at enhanced mobile broadband, ultra low latency, which are some of the things that we've not had before. So when I say ultra low latency, the next slide will just, I'll show you that you're looking at a delay of 1 millisecond, and then boom, you are online, or you have downloaded a movie in 1 millisecond or something like that. And it comes with some features such as a massive machine type communications, because, and this goes back to you. So we should all say we are contented at 4G, because the speeds for 4G, they're really, really reliable. I don't know, I've not met anyone who is complaining about the speeds for 4G. But what we are needing 5G right now, we are needing 5G beyond broadband access, okay? Why I'm saying beyond broadband access, it's because of the growth that has, the exponential growth that has come up in terms of the Internet of Things. So right now we are looking at having smart cities, smart water systems, smart security systems, smart lighting systems, connected vehicles, self-driving cars. I'm sure you've heard of these. Drones that are all connected and live streaming things in real time. You've heard of virtual reality, augmented reality. So those are things that are really high bandwidth consuming that 4G wouldn't support. And these are some of the things that now, 5G is unraveling and bringing them all the way to life. So so this slide is just, well, to give you an understanding that you can actually check what frequency you are using with your phone. I only have this for, it's normally called, this process called like a field test mode, where you are able to check wherever you are. All of us right now can be able to tell the frequencies our phones are using. And as I've mentioned, I think all of us within Nairobi have 4G coverage. And this 4G coverage, at the same time, it does not come, with the same, the 4G features I could be getting where I'm seated right now. They're not the same features that you'll be getting wherever you are. And that includes, the frequency you are using, your signal strength wherever you are, and the uplink frequency that you're using. Uplink frequency is the frequency your mobile device uses to talk to the base station, and downlink frequency is vice versa, the one that now the base station communicates to your mobile device with. So you can be able to check all that, and this slide I just put here so you could try it on your own, and put a link to some very good reference that can allow you to do this. I've done this with Samsung and iPhone users. I don't know the other phones, how they would respond to it, but you are able to check what frequencies you're using. And if you find the frequencies, they should kind of matching with what it's in the table, or that the Communication Authority have provided, then just know you're within the bounds of the LTE network. And that's sufficient enough. I keep saying LTE because 5G has not gone, we do not have 5G mobile devices in the market in the country yet. As quite a number of devices like Samsung have already started selling that, but you will still do not have them as widespread, partly because the mobile network operators are also just beginning to get to the round of deploying 5G. So these are the 5G features I just mentioned earlier on. So we are talking of a latency of 1 millisecond. If you're seeing just right below my south, let's call it what, this southwest there, and then I will have the user experience having 100 megabits per second. That is pretty massive. You have your data rates going at 20 Gbps. I mean, that 20 Gbps, you could be able to download a movie in a second, or download a whole software that is over 5 GB or 10 GB in a second. And that is really huge. And those are some of the things that 5G is coming in. And then you're looking at an area capacity of like 10 megabits per second per square meter. And that's pretty big. So 5G is as I'm going to, one of the slides I'm going to discuss something, you'll find that deploying 5G is a bit different compared to the earlier generations. It's not just the same levels we've been doing when you move to 2G and then move to 3G and then move to 4G. So 5G, a few things changes along the way, and I'll discuss that ahead. And then looking at these features, you have a network efficiency that is 100 times what we are currently experiencing with 4G. And then a connectivity density of like 10 raised to 6. So this is really massive, looking at the IMT 2020 provisions of the ITU. And this goes to the use cases I've talked about, so self-driving cars and all. So this is actually the real value of 5G. I cannot complain. Like, I don't know, but I'll hear this from you as part of feedback. I'll be happy to hear some thoughts on your experience of using 4G and sometimes 4G/LTE. So in your experience of using LTE, are you feeling like the broadband speeds are too slow? Are you feeling like you wouldn't work with that in the long term? That's so. If the fact that 4G has already catered for broadband access, the innovations that are coming up in the whole scenario of the industry 4.0, such as the pieces that are on this slide, are what they are calling us to now have the embrace for 5G coming up. And this is what you're calling future IMT. So IMT actually means international mobile telecommunications. And that's pretty much why, when you talk about 5G, 4G and all, they all fall under IMT bands. Yeah, so so this slide, in this slide, I just want to let you know one thing. So our deployment of 5G is a bit different from 4G due to the following reasons. 5G can be deployed in different bands, alternating. So at this point in time, according to the group that brings all the mobile network operators together, it's called the GSMA. Uh, it's looking at 5G being deployed in three different sets of bands. So the first bands, you're calling them the low bands, which are pretty much the sub 1 gigahertz band. And an example of that is the 600 and 700 megahertz. Now, for all of you, for some of you who think or have had this conversation where 4G can kill you or the 4G frequencies can kill you, 5G is actually operating. I mean, a 5G frequency can cause cancer and all, whatever myths you've heard about this, and probably I might hear thoughts coming, your thoughts on some of the conversations you've had with different people on this. 5G is actually operating in some bands below 4G. So, like for example, in our country right now, LTE/4G operates in 800 megahertz. But the initial deployments for 5G and some of the studies that have been deployed as pilots in the UK, in the US, and a number of other places as well, they have done the deployments for 5G in 600 megahertz and 700 megahertz. And this supports widespread, access with the indoor access of internet. And then you also can work within the suburban areas, can also work in the rural areas. And I think this is the low cost deployment for 5G because frequencies like these can cover longer ranges. So that would mean we need very few base stations for 5G. And this, in a way, would be the best ticket of us trying to bridge the digital divide, because since deploying in such bands is not as costly and can also be done in any area. So we are calling that the low band deployment for 5G. Now, the second band that 5G can be deployed in is called the mid bands. The mid bands, currently this is the band that's housing the majority of the commercial rollouts. Even Safaricom's deployment of 5G the other day was in the mid bands. And some of these mid band frequencies include the 3.3 gigahertz to like 3.8 gigahertz. So currently, I mean, I know the Safaricom network was just being done in 3.5 gigahertz. The 5G, the 5G network they were putting it up, and they're currently trying to scale in the other areas as well. So that has not really gone, to higher bands. And other bands that can be used in this also include 6 gigahertz and 4.8 gigahertz, and they're pretty much still within the way GSMA is looking at this. Is like these are the bands that will allow scaling 5G pretty much sooner than we get 5G in the higher bands. So the higher bands are the bands that we're calling millimeter waves. I'm sure if some of you have heard of something called millimeter waves. So millimeter waves, these are the higher bands that 5G is leveraged, that are being leveraged to deploy 5G actually. So the millimeter waves include frequencies that are way above 26 gigahertz. So 26 gigahertz is a bit high, 28 gigahertz is a bit high, but this is still again within the ITU standards that 5G deployments in the high bands will go to 84 gigahertz or 100 gigahertz. And we are talking about bandwidth supports of like 50 megahertz to 400 megahertz. Now, deploying 5G in high bands is pretty expensive because what millimeter wave calls for is you'll have base stations closely placed together. So if you're going to have like 5G within Nairobi, it would mean, imagine Tomboya having base stations almost close to each other and creating very dense hotspots within those areas. Now, I don't know about the future, but I presume our country might take a while before we get there because at this point in time, 3.58 gigahertz would still serve fine looking at the economic implication of deploying 5G. So these are two myths. I've heard of this before. Last year I got stuck in Europe and I had so many conversations, when COVID had just struck, and some friends also asking questions about 5G frequencies causing cancer. Now, for a country like ours, I mean, these are things we should not even, spend time looking at them, given that, and I said this in one of the webinars a while back, like as a bigger economy in East and Central Africa, we definitely have to think bigger and better. So 5G frequencies cannot cause cancer. Why? I've given you an example. You should be dead already since 4G is operating in 800 megahertz and you're enjoying 4G services already. So you should already be having cancer building up in you. Now, 5G operates 600 and all those are frequencies. But even now, looking at the bigger picture of the electromagnetic spectrum, which I began by showing you in the first slide, is frequencies in the radio frequency band are not ionizing. They are non-ionizing. That means they cannot dislodge your cells out. They cannot dislodge, your DNA or anything, or in a way mutate its makeup or something like that. For that to happen, you need high frequencies, very high frequencies, and that can happen with ionizing radiations like X-rays and gamma radiations. So you'll definitely have something like that happening with X-rays and gamma rays. But 5G frequencies, really, it's nothing with looking at there's nothing about your cells being damaged by such frequencies. They're too low. And then the second one I think I had was like 5G's relationship with COVID. To be honest, the two are totally and distantly related. Okay. You all, right now, I think we've all learned what COVID is, and we've all talked about COVID in a different corner. So looking at the way frequencies operate and the way COVID is being spread, I mean, 5G cannot stick on a surface that someone will touch and then you get the, COVID come from it, the way COVID is. So there's totally zero scientific evidence to actually link the two. So I think I had these are the two myths that I kind of were having conversations with different people about, unless others I'll get to hear through the thoughts that you are having, or some of the things that you've interacted with or people you've spoken to around the myths of 5G. So I think this brings me to the end of my slide, and I'm talking about the next trends in the next slide. And this probably might not be necessary in this conversation at this point, given that it's a fast conversation we're talking about. But 5G is actually going to have a lot of spectrum sharing. So we have something called non-standalone 5G, and then we have standalone 5G. So spectrum sharing, what it means is it's going to have the non-standalone 5G. So for example, like the millimeter waves I've just talked about, the 26 gigahertz, they are currently allocated for satellite transmissions, okay, fixed satellites. But now we are discovering fixed satellites, they're not like optimizing the 26 gigahertz. So it means we have to share that. And for us to be able to share that, we are able to, extend 5G connectivity through that kind of model of sharing that frequency with the satellite technologies. So spectrum sharing is going to be a big conversation in 5G. It's also going to be a conversation that enables more 5G rollout in as many bands as possible, because of the fact that spectrum utilization is not efficient as at now, based on the allocations that are normally given to services that do not consume those frequencies all the time. So that's going to be a big trend in 5G. It's going to go on and on for the longest time. For you people who've been reading some of the publications from Communication Authority or the releases of the new technologies, Communication Authority just authorized the utilization of TV white spaces. So TV white spaces is using the TV broadcasting band to be able to provide internet apart from the broadcasting. So that is an example of spectrum sharing that our country has begun having. So 5G is going to also experience a lot of the same. And then massive MIMO is just this means just MIMO means multiple input, multiple output. It's the use of many dense antennas to just get the signal of the 5G, giving us the ultra low latency we are looking for. And then air interfaces design. These again are some of the evolutions that are going to be happening, or the trends that 5G is going to pick up to be able to get its standards, because 5G is still evolving. It's pretty premature at this point to actually say one technology is being used for air interface. So that brings me to the end of my slide. I really didn't have much, but I wanted to just have that conversation, lay the ground in terms of what is 5G, and what frequencies does it operate on, what bands is it operating in, and are there any health hazards related to 5G, and at the same time, what is the benefit, what is the long-term plan of rolling out 5G for a country like ours, and what is the impact towards innovation. And I've mentioned the different use cases you can look out for. So that's what just I wanted to share in this conversation, and I definitely look forward to exchanging thoughts with you, hearing what some of you have heard of 5G, and probably answer some of the questions you might be having around it. Thanks. Thank you. Over to you, Richard.
All right. Thank you very much, Leonard, for very insightful communication. I feel I have learned a lot. Thank you for creating context, where 5G fits, and also just the motivation to have it by enabling essentially IoT capability and high reliability and reducing latency. So I'm excited to see what kinds of applications will emerge. So we can now go into a session of question and answer. I'll request anybody with a question to raise their hand. Perhaps I can start with one question, maybe a very layman question. So I remember when